Hi everyone, welcome back to Dragonfly Engineering. So this is part 2 of the Mastercam toolpath generation episode, making the geared arm gizmo. So if you want to see part 1, check out the link in the description below. Otherwise, enjoy the show. We can go through the sequence and a whole lot more of kind of the same operations. This is more of a simple pocket, and I did draw in my own sketches for some of these things to just facilitate hogging out or planing off the top of our gear. And then we did the same 3D high-speed dynamic roughing, but from the back side. So the mill actually flips the stock around and we start machining from this direction. And the way you set that is, again, you click on parameters, and under planes, you can see now that our work coordinate system is still top, which defines the actual fundamental mill itself. But now our tool plane and our construction plane are set to back. And you can change those by clicking and then picking back instead of front. So I'm sure what I did is I just copied the first 3D high-speed dynamic roughing and I pasted it into the design tree, and then I basically just changed tool planes from front to back. And then I'm sure I also updated the avoidance for our fixture to the back wall as well. And then I regenerated, and then now we get our front rough and our back rough. And then we leave a little bit of material to basically hold the part, or to tab the part into the stock so that it remains affixed to our mill so we can continue the rest of the machining operations. Let's do the verify on that real quick so you can see. So this is the roughing that we just did. And now it flips over to the back side, and then it 3D opti-roughs the back. And we're leaving basically a support rib in the middle so that we can continue with the rest of our machining operation. And again, with all of these operations, like this pocket for instance, you click on parameters and linking parameters, and then this sets all of the depths and clearances, so that when you rapid your tool up and out and down so that you don't plow through your part, well, you set that with feed planes, top of stock, retract position, and then depth of cut. So depth of cut basically sees whatever curve you selected to actually machine this part, which in our case, under chain manager, is this circle that I said that we chose, which I drew basically on the surface of this part itself. The depth of cut is the depth from the feature that you set as your driving feature. So since this curve is on 0, in our case under linking parameters, depth is 0, so we're machining to this surface. Now I could have done under cut parameters, let's see, I don't think I did, I turned off finish and everything because it wasn't necessary for this particular part, but you can actually set your machining scheme or also your finish by turning on finish. And then you can say, okay, I want my final finish, and you can to be 10,000ths or 1,000ths, etc., etc. You can also turn on and off the wear compensation on your mill, or you can say computer or wear or whatever. So, but we didn't need finish on this one. And again, we're now cutting the back profile of the part, doing the same spiral plunge. And this is just the most efficient hogging scheme, is a round circle for a full face mass removal scheme that the mill's doing here. Basically machining away all the stock except for the projection of that little angled foot on the end of the part. And again, this is the back side of the part. So you can kind of just see that rib that we're creating. And now we'll dig in to get more of the true profile of the gear and the arm. I'm just spraying some coolant to keep the aluminum at a reasonable temperature so it doesn't start galling and welding onto the cutting tool. You can start to see our gear head starting to form shape. And then we just kind of go down through all the rest of the operations. We can kind of just highlight these real quick. This is a contour path that I machined, and sometimes with some of these complicated shapes, you actually have to draw in your own wireframe, which is spawned from the actual 3D part itself. So if we go to parameters, toolpath, and then we go to chain geometry, and then figure out what chain we used, you can see how I drew this profile, which is this black and yellow profile, and I did that by basically going to the wireframe section, and then there's something called project. And of course, oh yeah, project. So you can pick a plane to draw on, and then you can click on 3D features, and it'll project those features onto your actual machining or your sketch plane. So I probably picked like this surface right here as my plane, and then I projected the sketch off of the 3D features. As you can see how we've got like an arc here, and this is just a vertical line relative to the sketch line. So you can actually create these projected profiles, which is really handy for 3D machining. And then, so we use this sketch to do this toolpath operation. And so you can see the machining, multi-step machining in blue off of our projected sketch, which is this one. Well, yeah. And that cut out the profile of our part, but we need to keep the bottom rib so that our part doesn't just fly off until the final cutoff operation. So here we cut out the bearing hole, clean up the bearing hole. These are just contours picking up, probably this edge I used. So you can just select, or when your mouse goes over a feature, it'll turn into this white and black dotted line. You select that for your machining operation. And down here I had to hog out some metal because then one of the next operations is a 3D raster. So you define the 3D high-speed raster. But with the raster, it's kind of a finish cut. So you got to make sure you're not going to plunge your end mill into deep stock and bust off your end mill in the process of doing a high-speed raster. So I had to cut away some of this material to prepare for, and actually just hog out extra material around our profile. But the 3D raster here is one that you got to be a little careful with, because you can plunge in deep into stock if you don't clear it out. But then you can see how basically the tool enters, comes up, and then starts a back and forth 3D profile, kind of like a 3D printer does, for our 3D surface. So we're machining the radius, the flat, and then the backside radius using a 1/4 inch square end mill. And then we can, you can actually animate any of these with backplot, and you can hit play or just drag the icon. But here you can see how it's going to basically profile. And the tool leads out so that you don't have like a lead in or lead out gouge. That's what this blue arc is right there, which is pretty nice. I mean, so it just leaves a better finish. You don't get crazy tool flexure gouge marks when the tool enters or exits. And it also does a little round transition where older toolpath programs would be a kind of a sharp edge, and you get deceleration, acceleration problems, and then funny little defects on the edges of your raster. Anyway, so that's the 3D raster operation. That was getting the finished face of the gear head. And here we are cutting out the rest of that frame, that chunk of metal, so it doesn't get all up in our cut later on. I'm going at 100% now. There it goes. I have to be sure to get that out of the chip bin. And now we'll do a tool change. Now we got our 1/4 inch end mill. And we'll machine out the axle pocket for the gear. Might slow this down a little bit. And then we finished our gear bearing hole. This is a clearance cut for the 3D raster that we're going to do next. I had to hog some of this extra material out because the raster is a finished cut, so it doesn't worry too much about if there's stock remaining. And the same on this side. So since we hogged out the rough stock with a full flute face machining operation, I got to go back and kind of clean up basically that original wall of stock on the lever arm itself. So that's what we're doing here. The mill always goes back to that safe position when it does tool changes. Here we're just cleaning up the profile of the gears a little bit better. Eventually we'll use a 1/16 end mill in there. Some of these are cutting air, but this is a short run part, so I'm not going to fuss about optimizing this for, you know, I'm not machining 1,000 of these parts. We're using the face of the 1/4 inch end mill, which is about 6.4 millimeters, to just hog out the mass that would be between the gear teeth, and just get us ready for the 1/16 end mill and the swarf cutting, which is always fun. 5-axis swarf cutting. We're following along and cleaning up the rest, and then we're hugging out the extra material that was on top of our lever arm on the backside too. And now we're 3D raster cutting our lever arm. This is like a filleted arm that's basically fully three-dimensional. So if I didn't clean out that stock in the base of that arm, with that 3/8 end mill, then I potentially would have plunged that end mill, this end mill, into just stock when it started its raster cut. Of course, that sheet metal's in the way. Let me pause. So I hit feed hold and spindle stop. Now I can open the door, and let's give you a better view. Actually, I'll clean up the window a little bit too. Now I can close the door, because this mill's got door interlocks, which I recommend using with 5-axis mills. Don't try to defeat them. And then if I hit cycle start, it'll turn the spindle on and continue machining. So this is filleting the arm, or rounding off the corners of the arm, and then starting to form more of the bottom of that that little foot with the gear with the tread on it. Starting to get full face at the end there. And again, you know, with the planes, this was set to the front plane, which is this guy. This icon tells you what plane you're on. And then we do the same with the back. Oh, I got to exit out of the demo. So here's the front, and then the back. You know, so we basically I copied the 3D raster icon, pasted it, and just said change planes to back, and that was it. Everything else, the tool, the feeds and speeds and everything is set, or the same, because you cut and paste. It saves you a lot of time. Then we'll rotate and then do the same on the back. Now for this operation, I didn't have to completely remove all of the metal, because with raster cutting, we're only cutting 4/1000ths, or about 0.1 millimeters per pass. So that's not an aggressive cut to cut away that original stock. But if I were to plunge into that, like on the other side, then I would have had to cut more of that stock away. Because end mills like to cut with their full face, like sliver cuts with the full face of the flutes. So it's just happy doing it like this. You can see we're following a 3D profile. And then it cleans up some spots that it couldn't get with a single pass. All right, what's next? Now, this is an interesting situation, because we had to create a new plane for this faceted surface. So the mill actually would rotate so that the spindle is looking down at this surface here. And to do that, you can go under planes, and what did I call it? I just called it the angle plane. But you can click on this plus, create new plane, and you can pick a feature from geometry, and then you can kind of zoom in and find a face that is in the right orientation for the plane that you want to create, and select construction plane by geometry, select an entity. So we hit plus. Okay. From solid face. That's what I should have done. And then you come down and you click on your solid face that you want to have a cutting plane for. And then here you can see a preview. It's a little hard, let's zoom in. And then you can choose which rotation of your plane you want. So we want, you know, everyone likes to have, let's see here, X that way, Y up, and then, or Y facing up, and then Z coming out of the screen. Okay, so we like plane 1 of 8. Because you got to, you know, there's 8 options for how this plane is oriented. So we say, yeah, we like that. And then we can name it temp angle. Or whatever. I've already made the angle, but anyway, so we just made this temp angle. So now when you go to your toolpaths, and if you want to, you know, machine on this new angled plane, then you can go to parameters. Let's see, well, let's pick one that's actually, okay, so like contour. You can go to parameters and then under planes. And right now I've got it set to angle, but we can also make it the new one that we just made, which is temp angle. And then that's your new plane for machining, but we won't do that. But that's how you do it. Anyway, so you can see how the tool enters in perpendicular to our angle that we defined, and that way we can profile this just like we're on a 3-axis mill with a crazy fixturing like that. And using that same angled plane, I did a 3D raster profile, which starts to cut in and define at least the edges of our tooth pattern here. All right, what's next? And we will now machine the face profile using this work coordinate and tool plane, which is real handy with a 5-axis, because you can set any plane that you want, basically. All right, let's keep going. So now we're profiling the foot, this angled foot on the end of our arm, and you can start to see the final kind of shape of our part emerge out of the aluminum. And here I'm just hogging out more clearance for later cuts. Starts to get a little rattly. Base on our little end effector arm pad here with the little serrations. This is going to cut like the kind of the arcing profile and the beginnings of the serrations. And this is just a 2D raster cut, or a 3D raster cut. Starting to get a little ring in the part, but it's not too bad. And the face of our gripper pallet, or paddle, or whatever you want to call it, does have like a kind of a subtle arc across the face of it. And then in the middle part where it's kind of hopping up right there is where the serrated kind of teeth are. We'll cut that next. Actually, I think we're going to do another 5-axis swarf cut to kind of cut the 45-degree sides of these not really knurls, but triangular tooth ridges. And then we'll finish cut with like a smaller ball end mill. And here, let's see here. I actually created yet another plane to machine these side angled tooth facets. Let's see what that is. So that plane is called ribs, and I basically did the same process, but I grabbed the face of the rib itself, which created an even more complicated plane. You know, because now our tool is entering from this goofy direction onto basically these rib faces here. So you can figure out the orientation of the plane that you created by basically looking straight down the tool plunge direction, like so. Let me get the coolant off. So here we're cutting the sides of our raised serrated teeth. Now swarf machining is an interesting operation as well, where basically this is a 5-axis operation. So with the swarf machining, the mill goes, it basically follows an angled wall with your end mill, and it doesn't care about what plane you define, but the mill actually figures out how to dynamically roll your part so that the edge of your end mill is following a side, like an angled sidewall. So that's what I did for this operation, and I think it's probably just easiest to show it. So we'll click on back plot, and I'll drag our icon to see the end mill. So yeah, and so you can see how basically with 5-axis swarf milling, which is a new thing that I've been playing with, which is kind of fun to play with actually. You can, I didn't define any machining plane, so the toolpath system thinks top plane, but as we play this operation, you'll see how the end mill kind of follows the sidewall of our teeth there. We can explain that a little better when we get into machining the bottoms of these teeth, these gear teeth here. Actually, I think technically this is the swarf because it goes to this weird angle and then comes in. Where the previous cuts were just parallel facets because these teeth are like 90 degrees to each other. So this is actually the tricky 5-axis operation. Yeah, well, the other one was also interesting, but it's a simpler cut than this swarf cut. You'll see it roll at the end here, which I guess we can just look at right now. Oh, and again with the angled plane, we finished up the teeth with a high-speed scallop finishing operation, which basically just it's an equal scallop, which is like the bump between two ball end mill passes, and it just swirled from the center all the way out to create our full profile there. And I did a similar edge radius machining operation with the same scallop operation. In fact, I can show you how you select those things. So if we go to parameters, model geometry, and you can see that I basically, for avoidance geometries, I told the toolpath program to avoid everything in the part except for what I wanted to machine, which is the actual features that we're going to machine, which are highlighted in green here. So you can see these are machining and avoidance. And with Mastercam, I do have a pet peeve with Mastercam in that if you have a radius that you're 3D machining and you don't have the tangent face of that radius marked as avoidance, then Mastercam will actually try to roll its 3D rounding operation around and down into this face. In fact, maybe we can just show that. So if I unselect this face and I say in selection, and then we tell it to update, you're going to see how the toolpath is wanting to dump down into the 3D part. Let's see if I can. Yeah, you see how it's how it's wanting to, it's following the profile, but then since we didn't make this plane avoidance, maybe see if we can get a better. The fact that we didn't make this avoidance means that the end mill is now plunging down deep into this feature, and then it's following its lead out all the way out, you know, which is super annoying. The comparison is this side where we made this plane an avoidance plane, and you can see how it's like, oh, okay, I'm not going to machine over here. I'm just going to machine this green part. So when you're doing 3D profiling, like rastering, you have, I had to restart the camera real quick if you're wondering what that little stop was. So anyway, this ruined many parts for me until I decided, or I learned the hard way, that when you're doing these new advanced 3D machining operations with Mastercam, it's best just to, and you want to select features only to machine, it's best just to select the entire part as avoidance and then go back and select what you want to machine. Otherwise, you're going to get all sorts of funny stuff like this. So let me go back to select, and I'm going to, for avoidance, I'm going to select this surface again, which highlighted yellow in selection, and now you see that we're red again. So it's only going to machine the green and avoid the red, and then we'll hit the blue check, and you'll see that it's going to figure, oh, now I'm not going to plunge into your part anymore. So that is kind of an annoying thing for me with Mastercam. My old 15-year-old toolpath software visual mill just assumed that you didn't want to plow into your part at all. But with Mastercam, you actually have to say avoid the entire part and just machine what you want to machine in green. So keep that in mind. So now we're doing a constant scallop 3D finishing operation to kind of sharpen up the teeth that we started to cut with that previous operation. We'll give it a little cool. So kind of going around like a record player. Started in the center and just going around cutting these diagonal teeth in. This is a ball end mill as well. All right, now we're doing the corner radiusing on the entire face of this foot plate thing that we've got going on. So we're blending in I think it's like a 1 millimeter radius or a 40,000ths of an inch radius all the way around. And I've sped everything up to 100%. I believe this is a 1/16 ball end mill again, but it could be a smaller ball. All right, and then as we go down more of our features, we get into the interesting swarf stuff, which may be a little more clear. So in this case, we did a contour machining. Let's see, where is that? This one with a 1/16 or 1.6 millimeter square end mill from this direction. And we're going to use that, and I'll probably slow things down a little bit, to basically profile our gear teeth. So we're going in and out, and since this is a spindly little end mill, we can't go super fast because it'll just snap off. But basically that end mill is going to machine the entire profile all the way down inside until it gray dust or mud that's coming out since coolant's in there. Then we go over and do a new pass, and we're going to do this all the way down. I'll probably time lapse this maybe, but the coolant needs to stay on too. So anyway, I'm gonna have lunch or something. But you know, our gear teeth need to have a sharp square bottom. So the 1/8 or the 1/16 end mill won't do that. In fact, we can do a verify right now and see what it would look like. But you can see here how, you know, our gear is going to have this round bottom, which we don't want. So to fix that with the 5-axis mill, we're going to do more of the swarf machining, or 5-axis swarf, which is this operation. So the mill will actually rotate this stock in 5-axis swarf machining so that the side face of the end mill is skimming along this edge of our first gear tooth bottom. So we can just scan that real quick. So you can see how basically this tooth, or the flutes of the end mill, are basically parallel with this surface that I defined in the 5-axis swarf machining operation here. And that basically allows us to get these square edges in the bottom of our machined part. Otherwise, you'd have to EDM it or broach it or do some other crazy filing operation to basically sharpen up the bottoms of these of our teeth. And I did that for each one of these. So we can open this swarf thing real quick, and maybe it'll be a little clearer what I'm talking about. So this is the kind of the meat and potatoes of it. So if we select on our swarf geometry, so we click on this guy. Oh, well, I've already got it selected, but anyway, this selection here would be this face, and then floor geometry, which is this selection, is the floor, which is this face. And then there's a whole bunch of questions to answer, like tool axis control is 5-axis, and linking parameters is always a good one. And you basically go through and answer all these questions. Like I think I said to do a multi-pass, multi-cut. And you just go through and you say, for instance, in this case I wanted 2 cuts because one cut was a little hard on the end mill. So you can see we did 1 pass, go up to the 2nd pass, and then face this edge off. And you'll see that there's not really planes, because in 5-axis, there is planes actually. But I guess it ignores the front planes, because in 5-axis swarf, the milling machine basically takes over and dynamically rotates everything around. But yeah, so we did one of those for each one of the gear tooth bottoms, the 5-axis swarf, and we can show that operation in the mill. So you can see we go around and we're cutting each side. Now we're going to do the swarf milling. Now we're hitting we're side milling the teeth of our gear. So this is 5-axis swarf milling, and we're basically cutting angled facets in our part by angling the part and then coming down directly with the milling machine. And then you'll see that we will adjust the angle and then cut the next tooth. It's a little tricky to keep up with the mill. But now we're cutting the next gear tooth profile, again with this long spindly end mill. I got the feed rate down to 70%, so we can do this without the coolant spraying, hopefully. I think this is a newer tool as well. I actually did multiple passes on this so that we don't bog down the end mill too much. But yeah, we're going to go all the way around this hemisphere, or this semicircle of gear teeth, until we're done facing all the facets of the gear teeth. And basically we are putting the sharp corner bottoms of the teeth in at this moment. The previous operation with a 1/16 inch end mill that was orthogonal to this cut was cutting in the actual gear tooth profile. I forgot what standard of teeth this is, but this is really just kind of finishing off as the tooth dives into the base of the gear, and we're cutting or machining the square bottom corners of the teeth in. And there we went kind of past top dead center, so the part had to rotate 180 degrees in the, I guess, the Z axis, so that we could then roll the part to the left again. So with this mill, it really just likes to roll to the left past 180 degrees. It can only roll to the right maybe 30 degrees. So it has to figure out how to work its geometry to finish the swarf cuts on the other side of the part, basically. That's where the long tool is needed to clear all of this structure on the rotary stage itself. You can see how you could run into issues, crashing the corner of the tool to the stage itself there. And then finally we chamfer mill with the little, the 45-degree in chamfer. Yeah, we can slide and watch how we actually chamfer out our edges on the gear teeth. Like so. Oh, neat, it shows a little trailing line or a preview. It's slightly darker or whiter blue color showing you where it's going to go. I think they must have added that. All right, next cut. Oh, here we're going to do the deburring. It's always fun. And then the final operation is to cut our part off of the carrier stock, which is this final cut here. And so basically this gear structure was held on by a tab, and then I actually broke the cut up into two sections so that we have a little bit of a tab left here and a little bit of a tab at the bottom, and then we just break the part off. So let's simulate the entire machining operation using Verify. So we'll select on Machine Group to select everything, and it shows all of the tool paths that we just went through. So it's a little tricky to see everything and see, oh yeah, this one blue line actually plowed through the part. You almost can't visually take it all in and find machining problems, but what you can do is simulate the machining. So we'll do that now. Do multicolor. For each operation is a different color. I may have to reset it for that though. Oh no, it's doing it. See, the blue is a new operation, and then back here it's like a purple color, and this would be the second 3D OptiRough, and then we're doing the rest of our machining. So here, this would be a chunk of metal that falls off into the chip tray, and you got to be aware of these. Sometimes those can hang up and cause you problems. And here we're machining on our custom angle, and then doing our ball end mill finish. And I think that's it. It showed our final cut and just a little bit of material left. Now it showed this as red, which normally means it's a gouge warning. I don't think it actually uses red, but since this is a final cutoff, it hasn't been a problem. And then this little sliver of sheet metal we just break off. And anyway, so that is our part that we machined. And yeah, so you break it off and we're done. We're gonna have to use coolant on this, I'm pretty sure. Maybe not, it's kind of a thin. So this is the first little kind of cosmetic cut. I actually didn't have those connected, but anyway. So I do a cut and then a finish cut, or a finish cut per pass. And that's it. Okay, we are done. We get the cell phone camera out. Let's break this part off. I'm going to zoom in and we'll see how it breaks off. There you go. This is our part. Now I'm going to sand off this tab and the remnants of the other tab on the belt sander. But we got a completed part here and one setup, minus just the tab cleanup. So there you go. So I hope you enjoyed watching this live or semi-live toolpath generation, I guess, overview. It's definitely not, I didn't tell you enough to be able to just go in and dive into Mastercam, but hopefully this overview gave you the impression of how to approach Mastercam toolpath. And basically, the best way to get good at Mastercam is to just do a bunch of it, and you'll develop a knack like any other software. So thanks for watching Dragonfly Engineering, and I'll see you guys next week.